Hello everyone, welcome to Spark Study. In this lecture, we will study about the race around condition, which is an important topic in digital electronics. We have studied about the flip-flop, D flip-flop, T flip-flop, SR flip-flop, and JK flip-flop, right? So D stands for delay flip-flop, T stands for toggling, a toggle flip-flop, and SR is the set reset flip-flop. One problem comes over SR flip-flop when S value is 1, R value is 1, we could not able to predict the output. Okay, output cannot be determined, so which is actually overcome in JK flip-flop. When J is 1, K is 1, the output is toggle, right? Toggle means whatever the previous state, okay, and that complement with the next state. So if previous state is 0, the next state must be 1, it's called toggle. Or when previous state is 1, out next state will be 0. So 0 to 1 or 1 to 0 transition is called toggling, right? So this is about the flip-flops. Flip-flop can be designed using a latch, NAND latch, NOR latch. So the race around condition basically comes in case of NAND latch. Okay, so whenever you have SR NAND latch, SR NAND latch used to design a JK flip-flop, right? So let's say you have a NAND gate over here and we have another NAND gate over here, and here is the S input, here it is the R input, and we can see if it is like this and if it is like this. Okay, so the output Q is connected to R, Q is connected with R, and Q complement is connected with S. So this condition using NAND gate is called SR NAND latch, right? So here the if your S value is 0 and R value is 1, the Q becomes here 1. In case of NOR latch, this Q becomes 0, but in case of NAND latch, it becomes 1. And when S equal to 1, R equal to 0, this Q becomes 0. So due to this kind of transition, our race condition occurs. Let us understand completely. Okay, so before going to the race condition, or to understand race condition, just understand something that is called race and toggle. Okay, both terms are near about same, but this depend upon the clock. So when the transition depends upon a clock, it's called toggle. That means previous state is 0, I am applying a clock, it becomes 1, again I am applying clock, it becomes 0, this is called toggle. But in case of race, previous state is 0, when I apply a clock, it will go to 1, and it does not depend upon the clock again come back to 0, go back 1, 0, 1 transition. When clock is 0, it again 0. So this is race. Race condition is independent of the clock, and toggle condition is depend upon the clock. Understood? Okay, so let us study completely about the race condition. We can see this is a table, and this circuit is belongs to the JK flip-flop. We used SR NAND latch, so instead of SR flip-flop, we can say SR NAND. So instead of SR flip-flop, you can say it is SR NAND latch. Okay, so this SR NAND latch, with respect to 3 input NAND gate, we constitute one more circuit that is called JK flip-flop, right? JK flip-flop. Here one of the input is J, second input is the output of the SR NAND latch, and third input is the clock. When the clock is connected both to the J flip-flop, J NAND gate and K NAND gate, right? So look at this table. When clock is 0, that means when we have not applied any clock, irrespective of the value of J and K, the output does not change. Whatever the previous output remains same. But when we apply the clock pulses, I mean when the clock is high, what will happen? When it depend again upon j and k value. When j is 0, k is 0, the output is the hold state. That means whatever the previous state, the next state will be the same state. That is called hold state. But when j becomes 0, okay, so when j becomes 0 and k becomes 1, the q becomes 0 and q must complement is 1. And for 1 0, it again becomes 1 0. But here in j and k, it should toggle. Okay, it should toggle when this SR latch is made up of NOR gate. Okay, NOR gate. But here it is made up NAND gate. So instead of toggling, it actually raise. Okay, it actually raise. So understand. Let us understand clearly using the example. Okay, so I told you about that. The raise condition happen only if the clock is high. So we can see in this diagram better that whenever we can see we have two different NAND gate over here, 1 and 2, and this NAND gate is connected to clock J and the output of the Q complement, right? So here let us consider how this circuit work. So when I make the clock high, that means this is 1, so this becomes 1, this becomes 1, and this condition j and k equal to 1 and 1. So this becomes 1, this becomes 1. Let us consider q equal to 0, I mean qn equal to 0, qn complement equal to 1, obviously. And this qn complement is connected to here, so this becomes 1. So first NAND gate, all the inputs are 1, and second NAND gate, 2 input 1, 1 input is 0. So the output of the first NAND gate becomes 0 and output of the second NAND gate becomes 1, right? So this is the output. Okay, now you can see we have studied that in case of SR latch, which is you designed using NAND gate, so when S becomes 0, the Q becomes 1. Similarly, Qn complement becomes 0. Now instead of 0, I am getting 1, and instead of qn complement 1, I am getting 0. So similar process again repeat. Here previously it was 0, now becomes 0. Previously it was 1. Here previously it was 0, now becomes 1. So instead of 1, I am getting 0 over here. Instead of 0, I am getting 1 over here. So S is 1, that means this is 0 and this becomes 1. So this is 0 1 0 1 repeat until clock is 1. But what should we expect? When clock is a constant value, the output remain constant, either high or low. But this never happen. Okay, so this is the demerit, and this demerit is called race around condition or racing. Okay, this can be better understood in the graph, that this is the clock pulses and this is the 0 value, this is up transition, this is high value, this is down transition, this is called up edge, this is called down edge, this is called level, right? So when k equal to 1 and j equal to 1, what happened? So before that clock is 0, so output we don't care about that, and when clock is 1 and it actually raise, so it's go up and come down, again go up and come down, again go up and come down, it continue, and now clock becomes 0, again it becomes 0, now it actually raise. Okay, instead of constant value, instead of value like this, it actually raise. So this period is called racing. Okay, what is called? This is called racing. This racing is a undesirable state because we need a constant output, but the output is fluctuating, right? So this racing condition can be overcome using this 3 method, that is called T half. I mean half of the time period of the propagation, half of the time period of the clock pulse should be less than the propagation delay of the flip-flop. So whatever, let's say my propagation delay of the flip-flop is 10 nanosecond. Okay, and the time period must be less than 20 nanosecond. Okay, so t by 2 is equal to 10 nanosecond and it should be less than that. Okay, so the time period of clock pulse is less than that of the propagation delay of flip flop. Okay, so if this is a time period t, half is here, this is t by 2, this time should be less than the propagation delay of the flip flop. Okay, second technique is, instead of using level triggering, use edge triggering. So we can go for this triggering and this triggering, so transition does not depend upon the triggering. So in case of edge, we don't have much time, suddenly it go up or suddenly go down, so this race may be stop. Okay, and this race can be completely removed using master slave flip flop. This is also called negative edge triggering. Okay, so you can see this diagram. This is the master slave flip flop. We have a JK flip flop is called master, which is connected to the input, and slave, which is connected to the output. Okay, QN, and this is QN complement. Okay, and you can see the clock is connected to both the input. Here clock is directly connected, here clock is complemented. Okay, so when J is 1, K is 1 and clock is 1, this master will race. Okay, and this slave will not race because here clock becomes 0. So this is toggle. Okay, so this race condition is generally overcome using the master slave flip flop. Clear? We'll complete the topic of race around condition. See you in the next lecture. Thank you.